In this lesson, you will learn about rational numbers. So the definition of a rational number is a number that can be written as a quotient of two integers. So an example would be the fraction of 1/2. Another example would be the integer of 12, because you can write 12 as a fraction just by writing it with a 1 in the denominator. Another example would be -3. You can take -3 and also write it as -3/1. And then a decimal, like 0.25. 0.25 is the same as 1/4. Another example would be 1/3, or the decimal 0.6 repeating. 0.6 repeating is the same as 2/3. A mixed number, 2.5, is the same as 5/2. And then also, when you have a square root with a perfect square underneath, the square root of 25 is equal to 5 because 5 times 5 is 25. And a final example would be the square root of 100. 100 is a perfect square because 10 times 10 is 100. So all of these are examples of rational numbers. An irrational number is just defined as a number that cannot be written as a quotient of two integers. And an example of an irrational number would be the square root of 24. The square root of 24 does not have a pair of factors that are the same, whereas if I go back up to 25, 25 is the same as 5 times 5, and 100 is the same as 10 times 10. So since there aren't two numbers that are the same that multiply to 24, the square root of 24 is considered irrational. Another example would be square root of 2, for the same reason. When you have a number under the square root symbol, you need two of the same numbers to multiply to it to be a rational number. And the third example is the number pi. So pi is approximately 3.14159, and if you were to put this number in your calculator, most calculators have a pi key on them now, you would see a decimal that doesn't end. So pi is considered an irrational number. So the directions are to write each number as a quotient of two integers. So if I take the number 0.96, this is 96 hundredths, where there are two numbers to the right of the decimal, which means we write 96 over 100. And then we just want to take 96 over 100 and reduce it. So I'm going to write the prime factorization of 96. I always take the prime number on the left and the composite number on the right. And then for 100, so by writing the prime factorization of 96, I'm going to expand the numerator as 2 times itself 5 times 3, and then in the denominator I have 2 times 2 times 5 times 5, and you get 2 2's to cancel, and you multiply what's left. 2 times 2 times 2 is 8, times 3 is 24 over 25. So once you write a decimal as a fraction, just make sure that you express the final answer in simplest form. So that's one type of question that you could have. Another type, number 2, is you have a mixed number. And this one is very simple. You just want to take the whole number in front, multiply it by the denominator. 3 times 7 is 21, and then add the numerator, which is 25. So your final answer is -25 over 7. -25 over 7 does not reduce, and this is our final answer. Now the more complicated type questions are when you have repeating decimals. When you have repeating decimals, there is a way to write that repeated decimal as a fraction. So what we do is we start with writing x is equal to whatever our decimal is that's given to us. So x is equal to 0.4 repeating. And then next to this, since I have one decimal that's repeating, I'm going to multiply the equation by 10 so that I have 10x is equal to 4.4 repeating. So if I had two numbers to the right of the decimal point, then I would have multiplied it by 100. If I had three numbers to the right of the decimal point, I would have multiplied it by 1,000. But since I only have one number to the right of the decimal point, I only multiply it by 10. And now that you have 10x equals 4.4 repeating, you want to subtract this equation, x equals 0.4 repeating, and I'm going to put this in parentheses. So that I have 10x equals 4.4 repeating, and then underneath I have minus x equals minus 0.4 repeating. My equations are lined up to where I can now add them together. 10x minus x is 9x, and the 0.4's cancel, and I'm just left with 4. Divide both sides by 9, and x is equal to 4/9. So if you were to check this using long division or on your calculator, 4 divided by 9 would give you 0.4 repeating. For number 4, 0.12 repeating. So I start with x equals 0.12 repeating. And since I have two numbers to the right of the decimal point, I multiply the equation by 100, since 100 has two zeros, and I'm just moving the decimal point over two places to the right so that I don't have a repeating symbol on the left, but I still have it on the right of the decimal point. So I have 12.12 repeating. Then I subtract this equation and I place it in parentheses, and I rewrite the two equations as 100x equals 12.12 repeating, and our goal is to cancel the part that's repeating. So this negative multiplies by x, and I have negative x equals negative 0.12 repeating. 100x minus 1x is 99x, and then 12.12 repeating and the minus 0.12 repeating cancel, and I'm just left with 12. And as my final step in solving for x, I divide both sides by 99, and I get x equals 12 over 99. So to reduce this fraction, I want to write 12 as its prime factorization and 99 as its prime factorization. So that I have x is equal to 12, which is 2 times 2 times 3, over 99, which is 3 times 3 times 11. The 3's cancel, and I have x is equal to 4 over 33. So always make sure your fraction is reduced, and if you were to take 4 and divide it by 33 by hand or on your calculator, you would get the decimal 0.12 repeating. For number 5, 0.45 repeating. So I start with x equals 0.45 repeating. And since I have two numbers that are repeating, I multiply x by 100, and I move the decimal point over twice so that I have 45.45 repeating. So once I have it set up to where just the decimal part is repeating, I subtract this equation, the minus sign gets distributed, and I rewrite the first equation. So I have minus x equals minus 0.45 repeating. These cancel. 100x minus 1x is 99x equals 45. And then I divide both sides by 99 so that x is equal to 45 out of 99. So 45 out of 99 is correct, but it's just not in simplest form. So I want to take 45 and split it up as 5 times 9, and then 9 is 3 times 3. And 99 we saw earlier was 11 times 9, and then 3 times 3. So instead of writing 45, I write its prime factorization, and instead of writing 99, I write its prime factorization. The 3's cancel, and I'm left with 5 over 11. For number 6, this one is a little bit more complicated because the repeating symbol is not over the entire right side of the decimal point. So there will be a slight change as we work out this problem. So I'll start with x equals 0.16 repeating. And this time, I want to get just the repeating part to the right of the decimal, so I'm only going to multiply this one by 10, so that I have 10x is equal to 1.6 repeating. And I'm going to subtract this equation, so all of my repeating parts are to the right of the decimal, and I have 10x equals 1.6 repeating, and then minus x equals negative 0.16 repeating. Now before I subtract these, I'm going to expand this one out one more decimal point. And what I mean by that is I'm going to write this as 10x equals 1.6 and then 6 repeating, so that when I subtract the second line, my repeating parts are lined up and they cancel. So that I have 9x equals 1.6 minus 0.1 is 1.5. So I divide both sides by 9. And I get x is equal to 1.5 over 9. And you never want a decimal in a fraction, so you want to move it over once, add a 0. So x is equal to 15 over 90. And then to simplify this, we want the prime factorization of 15 and 90 so that we can write this in simplest form. So 15 is 3 times 5, and 90 is 5 times 2 times 3 times 3. The 5's cancel, and a 3 cancel, and I'm left with x equals 1 over 6. And for the final question, very similar to number 6, we have 0.01 and then again just the 6 repeating. So I start by writing x equals 0.016 repeating. I want to move the decimal point over so that just the repeating part is to the right. So I'm going to multiply it by 100 because I want to move it over 2 places. So I have 100x equals 1.6 repeating. And then I subtract this equation. So minus parentheses x equals 0.016 repeating. And then I rewrite the first equation and distribute the negative in the second equation. And before I subtract, my repeating parts are not lined up. So I want to expand this one out and write my first equation as 100x equals 1.666 repeating. So when I line it up with the equation underneath, I can subtract the 0 and 1 away from the first two sixes, but my repeating parts will cancel. That's my goal, is to get rid of the repeating parts. So I have 99x equals 1.65 and I divide both sides by 99 so that I get x is equal to 1.65 over 99. And then I want to move my decimal point over 2 places, so I add 2 zeros, and I have x equals 165 over 9,900. So moving down the page, I'm going to write the prime factorization of 165 and of 9,900. So this 9,900 number is going to be very large. And when I take 165 and write the prime factorization, 5 is a factor because the number ends in 5. 5 times 33 is 165. And then 33 I can split up as 3 times 11. So with 9,900, I'm going to divide 9,900 by 5 because the number ends in 0, and I get 1980. Now if I divide 1980 by 5, I get 396, and 396 is divisible by 11 because the middle number of 9 is the sum of the two outside numbers. So if I take 396 and divide it by 11, I get the number 36. So now this problem doesn't look so difficult as it did earlier. And with 36, we'll go 2 times 18, 2 times 9, and then 3 times 3. So when we have x equals 165 over 9,900, and I expand out 165 as 5 times 3 times 11 over 5 times 5 times 11 times 2 times 2 times 3 times 3. We only want the prime numbers. 5, 3, and 11 cancel, and I'm left with x equals 1 over 5 times 2 is 10, times 2 is 20, times 3 is 60. So x equals 1 over 60.